lecture is the continuation of last lecture of integration. This course for Math 2 for the College of Management. Chapter 3 continuation. What about this? Last lecture we illustrate how to integrate by different examples. First, we save the rule in our mind, the rule which we are talking in the tables. After save the rule in our mind, we solve the examples again by yourself and check the solution with the answer here in the lecture. We speak about famous rule, and it is very important. We know before integration x power n dx is equal x power n plus 1 over n plus 1, and integration brackets power n, but inside this brackets is equation from first degree, meaning the power of x only 1, not more than 1. So integration f of x power n dx, and f of x is first degree is equal the brackets power n plus 1 over n plus 1. But here integration f of x power n, f of x here is function of x, and x is power more than 1, so x power 2, power 3, power half, power 3. To make integration function power n, it must be times derivative of inside brackets. What that mean? Integration f of x power n times f dash of x dx. F dash is derivative of the function inside brackets. If this happens, so the form here is equal f of x power n plus 1 over n plus 1 plus c, and n not equal negative 1, n not equal negative 1. We illustrate that for the next 3 examples. Example number 1, integration to x brackets power 10 inside bracket x power 2 plus 3. Here is the function x plus 2 plus 3 have power was after these brackets is 2x. So we have to think derivative of x squared plus 3 is 2x. So derivative brackets power, so integration brackets to power n times f dash of this inside brackets from the last rule, integration f of x power n times f dash of x is equal f of x power n plus 1 over n plus 1. Here 10, so x squared plus 3 power 10 plus 1 is equal 11 over 11 plus c. Remember, integration brackets power times derivative inside the brackets, the integration is equal the same bracket, but the power increase 1 by the new power. Look to the second example. Integration x times x squared plus 3 power 10. What's the difference between this example and last example? The same, but here no 2. First example is 2x, second example is x. So x squared plus 3 derivative of that is equal to x. Here is x. What is the 2? So divided by 2. So the same brackets power increase 1 10 plus 11 over 11. So the result is x squared plus 3 power 11 over 11, and don't forget divide also by 2. Why by 2? Because we are not have to here. Third example, integration 1 over x time 2 plus ln x power 8 gx. Look inside the brackets. Inside the bracket is 2 plus ln x. Make a derivative. Derivative of 2, 0. The derivative of ln x, 1 over x. Where is 1 over x? Is outside. So the rule here, the brackets increase 1 over, increase power 1 over the new power. So 2 plus ln x, here is 8. 8 plus 1 is 9 over what? Over 9 plus c. These 3 examples illustrate the rule exactly. Another rule. Remember from the table, the last lecture, integration a power x. What's a? A power x. Constant power x. Constant like 2 power x, 3 power x, 5 power x alone. Derivative z is equal the same exponential a power x over ln a. Meaning integration 2 power x is 2 power x over ln 2. 3 power x is 3 power x over ln 3, and so on. But here a power not x is f of x, any function except x. Look what the multiply. Multiply derivative of this function of the power. The power here f of x, here f dash of x. We treat as the rule a power x. So the result of the integration is a power f of x over ln a. We will illustrate that by the next examples. We say that the rule, by the rule or formula, integration a power f of x times f dash of x dx is equal a power f of x divided by ln a. Example 1, integration minus 1 over x power 2 times 5 power 1 over x dx. Here is exponential 5 power 1 over x. 1 over x, not x, is another function. 1 over x. Look for 1 over x. We can differentiate 1 over x. How to differentiate that? 1 over x is negative 1 over x squared. We know it before from differentiation. So the power 5 power 1 over x, the power here derivative equal minus 1 over x squared. So by rule is equal a power x. What's a? 5 power 1 over x. A here is 5 over ln 5. A ln 5 plus c. Another example, 2x times 7 power x power 2. The power here is x power 2. What is the derivative of x power 2? Is 2x. So 2x times 7x power 2 applies the rule is equal. Is exponential 7 power x power 2 over ln a ln 7 plus c. These two examples illustrate this rule. Now we speak about application of integration. We spoke before about application of differentiation. What is the application for differentiation? Number 1, giving cost. We want marginal cost. What can we do? Derivative cost. Number 2, given profit. We want to find marginal profit. What can we do? We make marginal profit. Integration is differentiation of profit. Third, given revenue. What is the marginal revenue? The marginal revenue is differentiation of revenue. So the word find the marginal meaning derivative. Okay, now we are in integration. find the cost, find the profit, find the revenue, meaning integration marginal. Find the cost, so the cost is equal integration marginal cost. Find the profit, meaning integration marginal profit. Find the revenue, meaning integration marginal revenue. So margin is derivative. So given derivative, we want the inverse of derivative is integration. Okay, we'll illustrate that by many examples. Look for this example. If the marginal revenue function is given by r dash of x equal 20x plus 5, so given here marginal revenue, find the revenue, find the revenue. To get the revenue, meaning integration marginal revenue. So the revenue is equal integration r dash of x. So integration 20x plus 5. To make integration 20x, integrate it is 20x power 2 over 2 plus 5. Integrate 5 is 5x plus constant c constant of integration. So the integration here is the revenue function is 10x power 2 over 2 plus 5x plus constant. Here's the constant. Look after that. Find the revenue function. Okay, we get the revenue function is equal 20x squared over 2 plus 5x plus c. Assume that the revenue is 0 when 0 units are sold. What does that mean? This meaning is the constant of integration is equal 0. So the revenue function is equal 20x squared over 2 plus 5x all day. So r of x equal 20x power 2 over 2 plus 5x all. This is the example. So given marginal revenue, we get the revenue. Marginal revenue is r dash. We want r, and here the constant of integration is equal what? Is equal 0, because we say that revenue is 0 when 0 units are sold. Another example. If the marginal revenue function is gr by gq is equal 2000 minus 40 q bar 2 minus 2q. R is the revenue, q is the quantity, meaning gr by gq means r dash. To get the marginal, here we have marginal, we want the revenue. To get the revenue, we must integrate what? gr by gq. So integration 2000 minus 40 q bar 2 minus 2q gq. We integrate with respect to q. So first one, 2000 to it is 2000 q minus 40 q bar 2 is 40 q bar 2 over 2. Oh no, 40 q bar 3 over 3 minus 2q. To it is minus 2 q bar 2 over 2 plus the constant c. We are not speaking about this constant, so leave it as is. So r is the revenue is equal 2000 q minus 40 q bar 3 over 3 minus 2 q bar 2 over 2 plus constant. Also, if the marginal revenue function is marginal revenue function, the r by q is 100 q to its quantity plus 2 q bar 3. Find the demand function. Demand function is the revenue. So to get the revenue, we have to integrate 100 q plus 2 q bar 3. How to integrate that? 100 q so is equal 100 q bar 2 over 2 plus 2q power 3 is 2q power 4 over 4 plus constant, leave it. So R is the revenue, or the demand is equal 100q power 2 over 2 plus 2q power 4 over 4 plus C, the constant. We have very famous example and very important. We look it in the exam like that. In the manufacturer of some product, fixed cost per week 5,000. See here, fixed cost that means the constant of integration. So the constant of integration is 5,000. You know that for the integration at the last term is constant. Here we take C as equal 5,000, and the marginal cost function is dC by dQ. C is the cost, dC by dQ is the marginal cost, equal 3q power 2 plus 2q minus 100. Find the cost first. Find the cost. After that, find the cost at q equal 150. To find the cost, we have to integrate 3x power 2 plus 2q minus 100 dq. Integrate it. 3x power 2 is 3x power 3 over 3 plus 2q is 2q power 2 over 2 minus 100 is minus 100q plus C. So C is equal 3q power 3 over 3 plus 2q power 2 over 2 minus 100q plus 5,000, because here C is equal 5,000. That's C. After that, we want to find the cost when q equal 150. See? We have the C function. So C at q equal 150, put for each q put 150. So it's equal 3 times 150 power 3 over 3 plus 2 times 150 minus 100 times 150. Again, C is equal 3q was instead of q put 150. So put 150 power 3 over 3 plus 2q instead of q, 2 times q square over 2, q power 2 over 2. So 2 times 150 power 2 over 2 minus 100 instead of q, so 100 times 150. Add, we get the results. All the last integration is called indefinite integral. Indefinite meaning the function, and plus the last constant is called constant of integration. And we know how to get the constant from the last problems which is given to evaluate that. Here called definite integral. Definite meaning integration from 2 is definite. So we can't find constant, and the result is have to be number. The result of the integration have a number. So integral from a to b f of x dx. First make integration f of x. Integration small f of x is capital F of x. And substitute capital instead of x, which is b is upper limit, minus capital F instead of x with lower term a. So equal f of b upper minus f of a lower. Integration from a to a, from number to the same number for the function is equal 0, because f of a minus f of a is equal 0. Make an example. Example from 1 to 2x dx. We will not look for the terminal. Integrate x. To integrate x is x power 2 over 2. And make the limit of integral. 1 down to up. Upper limit is 2, lower limit is 1. So substitute first upper minus lower. In this x, put 2, so it's equal 2 power 2 over 2 minus. In this x, put 1, so it's equal minus 1 power 2 over 2, and we get the result. Okay. Good luck. You have to solve many problems. You have a lot of solved example and solved questions. After that we have assignment number 5, a lot of exercise. We have to solve it to fix all these rules in your mind. Thank you.